we derived it. You guys all right with that? Okay, let me erase this over here, okay? You guys cool with that? In fact, well, let's put our first example up here. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus okay? Let's suppose we want to find S sub 4. That means to add up the first 4 terms. So that's going to be 1 plus 1/2 plus 1/4 plus 1/8. To add those, we need a common denominator, right? What's it going to be? What's the common denominator going to be?
8.
8. So 1 is like 8 over 8 plus 2, 1/2 is 4 over 8, 1/4 is 2 over 8, and then 1 over 8. So adding the numerators, 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So you agree that the sum of the first 4 terms is 15/8? You agree with that? All right, now let's use our formula here. S sub n equals A times 1 plus r to the n over 1 minus r. Now, you have to be careful here. N is not always the exponent we see when we write this out. N is the number of terms we're adding, and sometimes the exponent begins with 0. And so then n and the exponent are not always a match. Does that make sense? They don't always correspond. A is the first term. So for our problem here, S sub 4, A, what is the first term in this series? 1. That's your A. Times 1 plus r to the n. What is r in this series?
It's 1 divided by 2.
1/2. To the 4th power, right? Because we're adding up the first 4. Over 1 minus 1/2. Does everybody see where that came from? Good there? Yeah.
Isn't it supposed to be 1 minus r to the n?
Yes. Minus. I don't know why I wrote plus. Thank you. It would have come out wrong and I wouldn't have known why. There. Minus. Thank you. Any questions? All right. Multiplying by 1 doesn't change anything, so we don't need to show that. 1/2 to the 4th. So on top we have 1 minus. 2 to the 4th is 16. So 1 minus 1/16. 1 minus 1/2 is 1/2. 1 minus 1/16 is 15/16. That's like 16 over 16 minus 1 over 16. When we divide, we multiply by the reciprocal. And 2 reduces with the 16, makes it an 8. Same result we got over here. So, if you needed, we're not going to, but if you needed to add the first 100 terms, would you rather do it this way or that way? If you had to add the first 100, I think that way over there would be the preferred way. Yeah. Finite, geometric. S equals 3 times minus r to the n. So we did a simple example here where r is 1/2. Well, we'll hit some others later, but. Say that again? All right, any questions? So now we're going to talk about what happens when we carry this out infinitely. We know that this has a finite answer. We know from last week that the sum of that, starting with 1/2, is 1. That's when I divided up the square. The sum of that is 1, and if you add this one, you get 2. So carry this out to infinity, this sum will be 2. Well, what if it's not this nice? What if it's not this simple, intuitive? What are we going to do? That's what we're going to look at next. All right. Infinite geometric sum. Now, you gotta keep these straight in your head. If you're finding a finite geometric sum, this is the formula to use. So if you're finding the sum of the first 15 terms, the first 20 terms, the first 3 terms, the first 1,000 terms, this is what we're doing. If you want to find out what happens as n goes to infinity, then we're going to do what we developed here. Okay? Yeah.
Is that what you use when it diverges?
This is going to tell us if it diverges or converges, and then if it converges, it will tell us how to find that sum. Okay? All right, well, let me get some of these things out of the way on the board so they don't distract us. I'm going to keep the formula here. What happens in the infinite situation is determined by R. You can see there if R is 2 or if R is 3, like it was in one of those examples, 3 to the infinite power is going to be infinity, right? So we're going to get infinity going on in here. But if R is a fraction less than 1, such as 1/2, 1/2 to the infinite power is 0. And this goes away. Does that make sense? So we got to consider a few cases. The first case we want to consider, case 1, absolute value of R is less than 1. The absolute value of R is less than 1. What is the limit as n goes to infinity, whoops, of our formula? A times 1 minus R to the n over 1 minus R. Well, in the case where n is going to infinity and R, the absolute value of R is less than 1, we just talked about it, what's this going to do?
Go to 0.
Go to 0, right? 1/2 to the infinity is 0. 1/3 to the infinity is 0, because that denominator gets infinitely big. So in this case, then R sub n goes to 0, and we have A, because that's 0, 1 minus 0 is 1, times A is A, over 1 minus R. That is the formula for the infinite sum when absolute value of R is less than 1. Now, case 2. What about when absolute value of R is greater than 1? Then we should write it like, at least write this. This here goes to 0. So then do that. So then what happens to this limit? So if R is 3, or if R is 7, or if R is 1.1, anything greater than 1, what happens to R to the n? Goes to infinity. And this whole thing, if the numerators go to infinity, it diverges, right? Yeah. This thing diverges. Up here we could say converges. All right. There's another case we have not yet considered. What if absolute value of R equals 1? Case 3. Now let's look at this. Well, it's not readily apparent from the formula, because what's going to happen here in the formula, if R equals 1, 1 to any power is 1, so we can get 1 minus 1 is 0, 1 minus 1 in the denominator is 0, we're going to get 0 over 0, aren't we? So it's not readily apparent in the formula. So let's go back to this. The geometric series is of the form a plus ar plus ar squared plus ar cubed plus dot dot dot. If r is 1, then we're going to get a plus a plus a plus a plus a plus dot dot dot. Which if we do that an infinite number of times, and a is anything other than 0, what's this going to do? It's going to go to infinity, isn't it? Right? If a is anything other than 0, that's going to go to infinity. It's going to diverge. And we got to say a cannot equal 0. What if r is negative 1? Oops. Yeah, because remember, R, we said absolute value of R equals 1, so R could be negative 1. Then you're going to get a, if R is negative 1, that'll be minus a, that'll be plus a, because negative is being raised to an even. Raise it to an odd, you get minus a, plus a, minus a. That's going to just oscillate between 0 and a, isn't it? Right? Is it approaching a single value? No. So it does not go to infinity, but it does not approach a single value, so it diverges. It diverges if it goes to infinity, or if it just does not approach a single value. So diverges. The only case in which these things converge is when the absolute value of r is less than 1. That's the only case. The rest all diverge. So I'm going to write over here, infinite geometric sum. So the limit as n goes to infinity of s of n equals a over 1 minus r, comma, absolute value of r less than 1 is the condition. Remember, a is the first term. Sometimes the first term begins with n equal to 0. So that does not always match up with a sub 1. Does that make sense? And r is the common ratio. All right, any questions about those formulas? Forgot to wear my watch. 9:24. Any questions? You all believe them? Did I convince